Hello friends and welcome. This is the first episode of the Dr. TRSDOS channel. We want to welcome everyone. First I want to take a moment to tell you what this channel is about. This channel is dedicated to development, enhancement, and continuation of the TRSDOS operating system. TRSDOS was a popular operating system of the Tandy Radio Shack computers of the 1970s, 1980s era. The overall history from a 30,000 foot view is when Radio Shack stopped building the TRS-80 hardware in the 1980s. The TRSDOS operating system that provided the disk operating system for these computers ceased being further developed or any research going into this. There was no longer any hardware being built. There may have been some individuals build individual machines here or there that could execute TRSDOS either fully or partially, but there was no manufacturer or system being built any longer that could execute TRSDOS out of the box. Again, sticking with that very high altitude overview, TRSDOS was developed, I believe, by Randy Cook, who originally began developing TRSDOS for Tandy Corporation, who owned Radio Shack and needed an operating system for their computer hardware they wanted to resell in their stores. Things between Randy Cook and Tandy did not work out, and this project ultimately was undertaken by Roy Soltoff, Bill Schrader, Logical Systems, Mysosis. Roy Soltoff, I believe, makes the statement in one of his publications that he is the architect of the TRSDOS operating system, or at least the TRSDOS as we know it today. I believe when they took it over from Randy Cook, they were trying to keep things compatible with what Randy had already done and use some of his ideas, but they as much as possible created something new from scratch while still trying to retain compatibility with what was then something that was legacy. By the time Roy Soltoff took over, there had already been machines sold and was out there running, and of course Radio Shack wanted to still be able to provide software and support to these existing customers. All that being said, we ended up with sticking with this high overview. We end up with an operating system that no longer has any new homes being built. The only homes that it could be housed in and executed was either emulators running on newer hardware such as PCs, emulators for the Model 4, Model 3, Model 1 computers, or using the actual machines, green screen, gray screen, plastic hard cased machines. So actual hardware. So that was the limitation. You could build a Z80 based single board computers, and I think perhaps some people did. Different ones for different different models. I'm not sure anyone ever completely duplicated a Model 4 where it had the Model 1, Model 3, and Model 4 all in one package. But you still have the hardware problem. If you build a Z80, each person that built one had their own addresses layout of how it worked for their peripherals. Each one had their, so it was hard to make an operating system that would work on all these different hobby-based computers or small computer builders hardware. This kind of started to change when the eZ80 chip came out. When Zilog started moving to a more complex Z80, it still runs all of the Z80 software almost 100% unchanged. Only a few small details have changed. You might have to change from actual Z80 code. Most of it having to do with configuration or memory, but for the most part, your Z80 code runs exactly the same on an eZ80. However, Zilog added peripherals such as serial ports, parallel input-output ports, digital I/O bits, spare ones that you can use to interface to anything. And they also included a timer. And this timer is very important because we need to generate 60, we'll talk about this later, but we need to generate 60 Hz interrupts for the operating system. All of these were put on board one chip by Zilog and integrated together with the CPU. Now when I write software, it's the same addresses on my machine as it is on your machine to get to the serial port or to get to the timer. It certainly makes the programmer's life a lot easier. And we'll get into this more later, but they provide more than one chip. The eZ80 F91 and the F92. And also I want to point out this is the Acclaim series. The eZ80 series has several different chips. We are working in the Acclaim series of chips. And we'll see that when we go to their website. So also we're going to cover the TRSDOS operating system, which I've already spoke about. Then we have TRS-OS, which I'm the author of, and what TRS-OS is and what it does. We want to touch on the Zilog development system, ZDS, that we can download from the Zilog website, and I'll show you how to do that and where to get that software, and that's free. And I want to point out also it has a simulator for the eZ80 and its UART port. So we will actually be able to write simple programs, run them in the development system, and you can see the outputs to the UART, and you don't have to buy any hardware. It's all just... and of course we want to touch again on the eZ80 chips themselves, the Acclaim, the F91, the F92, and slightly on the F93, what they are and what's available in those models. So at my website, danielpaulmartin.com, that's DanielPaulmartin.com. If we go down to my research, the only thing I researched today is my hobbies. And that was TRSDOS, which I've been using TRSDOS the biggest part of my life. I guess I was first exposed to it in 1978, 1979, the first TRS-80s I came into contact with at my local Radio Shack. First we'll start off with the TRS-OS and what this is. I authored this piece of software down through the years. And what it allows us to do is execute TRSDOS 6, which is also known as LSDOS 6.3. The reason it's known as LSDOS also is after they released it to Radio Shack, they also was privately released from Logical System. The LSDOS, just simply renamed it LSDOS, marketed it under their own abbreviation. TRSDOS left off at 6.2, was where Radio Shack Tandy quit. After that, Logical Systems released 6.3, which they updated the date structure, and this was their last release of the operating system. So we can execute TRS-OS, loads into hardware, and provides the services and facilities needed for the legacy operating system, LSDOS or TRSDOS, to then be loaded into memory and execute. And as far as LSDOS knows, for the most part, it's running on the legacy hardware. However, we're now executing up to 5,000 times faster, maybe more, than the original hardware. So quite a difference in speed. This required all new drivers. We needed new drivers to interface to the hardware, and a new way of doing things on a lot of the structure of the DOS itself. We had to find some new ways of doing things, but for the most part, it's running unchanged. And in fact, to prove it to yourself, the DOS is made up of 13 overlays, overlay 1 through 13. Overlay 0, SYS0, contains the resident portion of the operating system. TRS-OS replaces SYS0, the resident portion of the operating system. But the overlays, overlay SYS1 through SYS13, so there's 13 overlays. You can run the original ones, you can copy them from a disk from the 1980s onto this modern platform, and they will run unchanged. Roy Saltoff, and I'm sure others at Logical Systems, realized that device independence or portability was the future, and keeping the operating system and its applications as independent from the hardware as possible was the way to go for the future. Today we see this a lot more. All systems today are pretty much built modularly, in modules with the modules with access directly to the hardware in a limited set of modules, and we know exactly which of those modules are. When we need to port to new hardware, port an operating system or some type of software, we know which modules need to be changed, and you fix these modules, and miraculously your application now runs on new hardware. And there's nothing better than the feeling of seeing a program you wrote 40 years ago, you load it into a new machine, and that same program is running unchanged. So they were very big on portability. That's why TRS-DOS was designed with an API, an application programmer's interface. And with this interface, we do not need to know where the physical location that a routine, such as converting a decimal to a hexadecimal number, we don't need to know where that routine resides in memory. We simply call that API for that routine, and the operating system knows where the routine is located. We'll execute that. And in the case of TRS-DOS, it uses a complex system of overlays, which really gives us a lot more bang for the buck on the 64K memory. If many of the TRS-DOS functions are located in overlays, And if you ask for a function to be done and that function is not resident in memory, TRSDOS will reach out to its overlays and get this function, execute it, then return to your application. You don't even know it happened. In the older days, when everything was running on floppy, it did slow the system down, getting overlays off of floppies. But today we're running the overlays in RAM drives, and I don't want to say it's instantaneous, but it's very, very fast. On my website, under the tab of how does TRS-OS work, it goes into a little further description. We're providing, these volumes are the same as disk drives on a physical hardware machine. So we're providing, depending on how much RAM you have on your eZ80 single board computer, we're providing a couple of 180K drives, maybe two 360s, a wide range of combinations can be set up there. You have support for 8 simultaneous volumes. I just recently added to where we can network with a PC, and some of these volumes can be located on a PC elsewhere. We can take these volumes down and mount new ones in their place while we're running. We support a wide range of disk formats of the original machines, and that comes in handy if you want to bring files or software over from the legacy machines. We have a 13 megabyte per volume limitation. That's a limitation of TRSDOS. Back in the day, that seemed like a lot. Today, well, we would be hard-pressed to store photographs from your digital camera on TRSDOS, but even that, there would be ways to get around it. Very importantly, we have 2 UARTs, UART0 and UART1. We present these to TRSDOS. I've wrote drivers for them, so TRSDOS sees these as an in fact. Our console is UART0, and it works as our system's console. And I recently wrote new video drivers for the console, and we're pretty well running TRSDOS memory mapped video. Is pretty well running real time over a console port to a VT100 base system, and it's emulating the video almost 100%. I don't want to say 100%, but we have a high degree of correctly displaying the original TRS-DOS video in games, things like that I'm referring to. We've had some work done on the AGON side. Man by the name of Sean Sinistra. I'm not sure how to pronounce his last name. I'm sorry, I'm probably butchering that up. But he's very dedicated to the AGON project. He has done a lot of work in creating fonts and a package to connect with TRS-DOS and emulates the old character-based graphics of TRS-DOS on the AGON machines very well. We get a real-time clock. Here, another big advantage of us all using the same CPU. We can have a real-time clock with the date and time, and this will the same address, peripheral address on everyone's machine, and it makes it easy for us to write operating system software to deal with that and use that hardware. So TRS-OS also is providing a complete set of BIOS So that's mainly what needs replaced. When you port TRSDOS to a new machine, the BIOS that the API and the operating system is setting on, the BIOS is pretty much all that needs to be changed. That's no small undertaking, but that's what needs to be changed. There's a wide range of eZ80 peripherals available, and we can configure to work with any of these. We can see here there's a list of the different areas. I'm not going to go into the details in this introduction today, but here's a complete list of the different sections, such as video, the keyboard, the printer support, and how that they are supported via TRS-OS to TRSDOS. So, how do I get the TRS-OS? I have a link here on my website, and if we click this link, it will give us some more information. And it's important to note that the two different acclaimed chips, F91 and F92, I have created TRS-OS to where it recognizes when it's booting which CPU it's running on, and then it adjusts or reconfigures to that CPU. And that's not a small task. It's not trivial in that they have completely different interrupt structures and things, but it will detect on boot. I had plenty of memory, so I was able to provide both systems, and then we could, adjust as we're booting and get rid of the one we don't need, etc. And yeah, so one load module supports both the F91 and the F92. Circle M, we have the AGON computer is supported. That's new. The Circle M, which you'll find on 10D and other websites. Circle M, you can Google Circle M, MZ80, eZ80 here. Take you right to Bill's website where he sells these. He has two models. One is based on the F92 and the other one based on the F91. The F91s are 50 megahertz and the F92s are in the 18 megahertz range. It's two different worlds when it comes to hardware. The 18 megahertz, a lot of normal. I said normal system. I don't really mean normal. I mean something more in the TTL or CMOS based development tools will work nicely with the 18 megahertz machines. However, the 50 megahertz machines, you need a completely different set of development tools, and 50 megahertz. I'm not saying that the eZ80 is as fast as a Cray supercomputer, but what I am saying is 50 megahertz are the signal. You're talking the original Cray supercomputers. You're talking signal speeds that was used in the Crays. This means that to interface memory, to have address decoding, things like this, it's not the same as it would be when you're running at 18 megahertz. You need to use a completely different level of technology, and unfortunately, that X's a lot of people out, including myself. I don't have those type development tools and the expense of using things like that. However, on the other side, the eZ80 comes in development modules, where the beauty of all this is, so many of the peripherals are already built on board, and also address decoding signals, etc. has all been done for you, and those signals are provided even on the 50 megahertz machine. These signals are provided from that small processor card. So that if you want to interface to a TRS-80 peripheral that was running at 4 megahertz, you'd still be able to do that. So yes, mainly development tools where you're talking to memory or something that's on the high-speed bus that you're wanting to run at high speed with no wait states. That in the 50 megahertz module is where you need specialized development tools. Otherwise, the 18 megahertz model, you're able to use more widely available development tools that we've used in the past. So if you're wanting to have your own, you would follow this link and you could download it from here on GitHub. Now, if you're running also the AGON hardware, then you will need the loader from AGON. And then let me search here for that. We're going to search on Sean. And of course we didn't find. So let me take a look at this and I'll come right back. Okay, so I had to correct myself on the spelling of his name, and the last name Sinnstra, and he's here on GitHub. And for as you can see here, he has some websites and various things. So he has a lot of products here for the AGON. Sean's very into the AGON development, and he has a loader here. I must admit I don't know a lot about it. I don't use it. I don't use the AGON other than when we're doing development work on it. But you can see here he has a wide range of products that he's supporting, and he has a loader here for the TRS-OS. So in the search line up here, if we put in TRS-OS at his site, it's going to come up to the AGON projects, and we're not going to go through the entire downloading. We're only going to touch on this, but we can see he has OS boot. OS boot, there's a README file here for this, and you can get further into, if you have an AGON, you know what he's talking about, and he'll have the code you need here to download and run in order to run TRS-OS. So if you have the AGON, make sure you get with Sean. On our Facebook site, we have a Facebook page, and you can easily get to that by typing in www.TRSDOS.com. Sean is our resident expert on AGON, and he certainly can help you get running, and I'm sure will be happy to do so. I also said that we could use TRS-OS on Circle M hardware. Circle M is out of Canada, and we got a great machine in the Bill McMullen up there at Circle M. So if you Google Circle M Canada, I get these results, and if we go look at his 10D, we can see the 50 megahertz system. Now this is one that we can run TRS-OS, or here's the one that's at 18 megahertz. These are very small. He calls it the eZ80. It really is. It's a 1 square inch or something like that. It has all the hardware packed in that you ever need to run a complete operating system. And here he mentions the TRS-OS also. Now, if we go back to my website, I list the features of each chip, the F91 in a block diagram, and then the F92. The F93, there's a little note down here that it's even smaller, supports 64K of flash and 4K of static RAM. So that means they've dropped out the 8K static RAM here. This one has 128K flash. The F93 has, I made a note down here, has 64. So the F92, the difference between it and the F91, for example, they left off the Ethernet on the 92. They put in less flash memory. So this reduces costs, brings it in at different price points depending on what job you want to do. Again, the 91, your 50 megahertz is a very high rate of speed, clock speed. The F92 at 18 megahertz is a little more manageable for the hobbyist if you're wanting to wire directly into memory, things like this. If not, and you just want to use a building block and then adapt your own peripherals and things to one of these building blocks, it's not that difficult to do. In fact, it's probably easier than using just a standard Z80 chip. Here, there's a lot of address decoding been done for you, chip selects and things like that. It has a chip select and wait state generators built in. You don't have to build the circuits for that. It has internal clocks, interrupt controller. All these things are built in for you, and you don't have to. And some people have said, well, if everything is all built for me, then there's nothing left to do. Well, yeah, there is. That's to pick up where we left off with the Z80 and goes back to this statement right here. Where does TRS-OS go from here? Well, you can look at this hardware we have. There's a lot of software needs to be wrote for this hardware to take advantage of all this new hardware. That's where we need to go from here. Okay? I want to thank you for listening to this video, and hopefully you're going to be a follower here at the Dr. TRSDOS channel.